Fantastic. Brilliant. Okay, let's get on. So we're going to have George Floros is going to be joining us in just a moment. George is Head of GIS at Skanska, with a big focus on geospatial digital twins and a very customer-centric philosophy, which I think is really important for the introduction of any kind of new technology into the space. George is going to be talking about the implementation of digital twins on complex, large infrastructure projects, the deployment of data-driven digital solutions, and the importance of trusted data, which I think is really interesting. That trust in data is really important. It aligns with everything else that we've been speaking about over the last few days in terms of AI and so on as well. So without further ado, George, please take the stage.
Great. Thank you, Richard. Hello, everyone. Good morning. I would like to thank the team for the invitation here today. My name is George Floros. I'm Head of GIS. Just a quick show of hands. Who here is familiar with the term of GIS? All right. That's one of the rare times I don't have to explain it then, which is great. Is there a click? Oh, I can use this clicker. Right. I should. There you go. Right. Today, I'll be talking to you a little bit about how we are using geospatial data as well as construction data to create what we believe is a representation of the physical asset on site. Skanska is a global civil engineering company, so we are working across the buildings, facility management, the infrastructure sectors all over the world. I'll be sharing examples today from our infrastructure sector, which we find is particularly complicated when it comes to managing all these different stakeholders and interfaces. So I would like to start with some of the key challenges that we are currently facing on our projects, and then the importance of data, interoperability, and the concept of digital twins, how this can actually be applied on practice. The role of geospatial in BIM, and I would like to focus on three use cases actually that are hot off the press. One is how a quality management system, a health and safety management system, and environmental management system. And then we will discuss a little bit the outcomes and the benefits that we have seen so far from our effort. So when it comes to challenges, I think everyone in the room probably has experienced this or something similar to this, but the nature of the work we do is very much project-based, right? And when we are working at infrastructure and we think about the highways, the rail, the water, the energy sectors, there are all these different customers, all the different requirements, all these different construction methodologies, if you'd like, and stakeholders that we need to be able to bring on board. And this creates some challenges when it comes, to this cross-disciplinary collaboration between the tier one contractors, the clients, the technology partners, as well as our supply chain. And this is something that is really important to us, to be honest. Like, if we want to have a meaningful digital transformation, we need to make sure that we are able to bring all of these stakeholders on board. Of course, there are a lot of regulatory compliance that we need to make sure we adhere to. And Skanska in particular is paying additional focus on health and safety, as it is something that is very important to us. The fifth challenge is one of my personal favorites, which is the dynamic nature of the construction industry, the continuous change, the continuous, like how do we move from a reactive to a proactive approach? And hopefully this sort of paints a picture of why or how the digital twins could help us. Before we jump to the examples, I guess what I would like to say for you to take away, hopefully, from this slide, and that has been our experience and might be a little bit controversial, but it's not always, we don't always need a digital twin, right? And a lot of the times we see more of a digital twin, as a methodology or as a journey, rather than a particular technology or solution or an outcome. And you can see here, how the National Digital Twin Program defines the maturity levels of the digital twins. Of course, organizations adapt it according to their specifications. But I think it's quite important to know that sometimes it is okay if you build a digital model. It's okay if you build a digital pseudo, as long as it solves the problem you're trying to solve. A lot of the times, creating a digital twin can lead to over-engineering, can lead to issues around, like it is quite expensive to maintain. Do you have the right data? A lot of the times we look to run before we're able to walk. So this was one of the key things that we want to make sure we do right. And we've seen some really great examples, especially in our keynote today from Unity in terms of how powerful visualizations are. But what I would like to highlight here is the importance of seeing behind the digital twins, behind the ability to connect to real-time information and utilizing Internet of Things. I think that what stands out for me is the importance of having the right data processes and the right standards in place to make sure you can maximize the value of any technology investment we're making as an organization. And I cannot stress this enough. It's very important to link your digital twin with your business capability model and what your organization actually aims to achieve. I'm going to share some examples around that in a few minutes. So in construction, what we are typically having, so I'll be discussing a highways project, right? In a highways project, we have all these different engineering disciplines working together, from highways to structures, to technology and utilities, and of course, to actual construction management and construction delivery on site. And this is where we found like geospatial is a particularly beneficial capability when it accompanies our data, our construction data, because it helps utilize location intelligence, or in a slightly more technical term, location acts as the primary keys of primary keys. So what it does actually, it's able to take all these different information and data streams, integrate them, federate them in a single, if you would like to call it, common data environment or view of the project, which then allows the utilization for specific use cases. Applications vary from health and safety to sustainability to operations, as well as digital rehearsals and simulations. These are all applications and capabilities where digital twins, or an equivalent of a digital twin, hopefully can help us deliver projects faster, better, and safer. And this is where we've identified, two key information streams. So we have building information modeling, that everyone is familiar with, and also geographic information science or systems. And essentially, the main challenge, or the primary vision that we wanted to address, is how we are able to enable the collaboration between all these different stakeholders, and how we are able to democratize, if you'd like, all the thousands or hundreds of thousands of data that are typically produced during the stages of design and construction. And hopefully you can relate with some of the biggest challenges that I've identified here, which, of course, number one is interoperability, right? A lot of the times people are able to produce their own data. They are working in isolation, they're working in siloed ways. A lot of the times now we're moving to common data environments, which is a great step towards this collaboration, but still it can be quite tricky and difficult to access data almost on demand from different construction sources. And this is where the notion, of BIM and GIS integration, GeoBIM, if you'd like to call it, comes into play, because it acts as this federation, the digital foundation, if you'd like, of the project, that allows you to bring all these data almost with a click of a button in a single view. And from there, you start building capability. But in order to get to this point, you need to make sure that your data is coded properly, is standardized, you have the right verification and assurance methods, because people start using this for information, rather than for information and for decision-making, rather than just visualization. So the project that I'll be describing today is the work we are doing on behalf of National Highways. RTP stands for Regional Delivery Partnership, A428. It is a 10-mile dual carriageway in the Cambridge area. And essentially, it is a project that is quite complicated when it comes to engineering works, as well as stakeholder interfaces. So the first use case is, I would like to share with you how we have been able to transition to a fully digital and data-driven way of managing permits and construction operations. I will focus on two particular examples, environmental and health and safety. So hopefully the videos will kick in, which is great. So on the top right window, we see our environmental hub, and on the bottom right window, we see our health and safety hub. Essentially, what you're seeing here, or what I would like to highlight, is the value add of creating this data and location data-driven workflows. What you're seeing in both examples is how we are able to make sure we consume design and construction data to ensure that there are no environmental or health and safety incidents on site. An example of what you're seeing here is the entire construction team has complete visibility of all the different environmental species, habitats, ecology surveys, protected areas before they go actually on site to do site clearance, for example. And if they tend to raise a permit, when they want to raise a permit and they identify there is a spatial class detection with this area, the system is prohibiting you from doing this and is improving or is raising awareness that there needs to be an ecology mitigation process first before you actually work on site. And it becomes even more important when we think about health and safety and the management of underground assets such as utilities. This reduces in great way the potential harm of striking an underground service, which is quite important, obviously, first and foremost, for the health and safety of the individual on site, but it can also lead to huge program delays during construction delivery. Before we jump to the next slide, there are a lot of unique characteristics here in terms that underpin our solutions, but the one I would like to focus on is obviously the last one, which is the integration with common data environments, because it's very important to note, once again, that people are making decisions of this data. So we need to make sure that we are constantly serving them with the right data. The second use case is how we have been able to digitize a quality management system using building information modeling and geospatial. So for people, I'm sure probably everyone is familiar with this, but there is a process in construction called inspection and test planning. And as part of the inspection and test planning, you are supposed to raise check sheets with regarding a specific part of works. And these check sheets sort of confirm whether you have acted up to spec and is being used and is being kept as a record for future non-conformances, RFIs, defects, and they eventually becomes part of the health and safety file during the handover stage. So we have tried to simplify the process to a few key steps. So firstly, everyone in the designated construction person is able to raise a check sheet about the particular work that they're working on. This is being shared with a subcontractor and the supply chain in a digital way. So that means they can respond, review it, and capture the feedback. It is then being sent back to the engineer for a closeout, and it can always be audited by an independent checker throughout its entire life cycle. And it was actually a really big step to move from the traditional way of managing these check sheets into a digital way, and actually getting the people, the buy-in from the team was the most significant challenge. There were a lot of technical challenges as well, which can always be resolved by the buy-in, and actually make sure that this is being utilized on site was one of the key ones. So for this reason, what we are building here is something that we have built through a lot of stakeholder engagement. So it's not just a digital team sitting on their offices, creating all these amazing digital tools and then going off to the engineers saying, use it, because our experience has been that this will not work. So this was a multi-collaborative exercise. So we brought the digital disciplines together. We brought our engineers, we brought our client, our supply chain to make sure that they are feeling comfortable and actually the system is doing what they want to do rather than what we believe it is the right thing to do. And you're seeing here an example of moving into the 3D space of how we're able to raise, what is this one? It's a pre-concrete inspection straight off the 3D model. So what you're seeing here is the engineer is able to designate the area that they will be working on. As they do that, you can see all the different aspects of the 3D model are being highlighted and selected. And then a drop-down list is being populated. It's a Uniclass code specification for people that are familiar with these data standards. We are isolating the piles, prevents human error. But also what more importantly does is it provides the digital connection, because you can see the asset ID here. This is what acts as the primary key between the check sheets, between the form and the 3D model, and provides the permanent connection between what has been built versus what was planned to be built. This can be extremely useful, obviously, for construction progress and productivity monitoring when on site, but more importantly, the handover process becomes far smoother because this is all managed as a digital record, and through the right code and standardization, the health and safety file can be auto-generated within a few weeks. What we are seeing here is the second step of the process of once a check sheet is being raised, how the supply chain, the subcontractor on getting on board, they are responding, they're reviewing the comments, and the workflow kicks on. And this is the example I was mentioning earlier. Once we start going through raising check sheets in a digital way, it becomes much easier for our construction managers and the project managers on site, as well as on our clients, to give them the confidence that we are building up to spec and we are building according to program. So these were the two use cases. I would like to briefly summarize the outcomes we have experienced. So there are significant, when we move to digital ways of working, there are significant savings around time, right? We have been able to reduce the workflow, the process, or the time needed, to manage hundreds of tens of thousands of permits up to 83%. This has given us a significant amount back in time savings. And the most important thing, or something that we are looking at now, is how do you actually utilize this for further benefit of the project? Can it be improving your engineering capability? Can it be improving, like introducing new innovation that the client is able to get on board? It's very important to make sure, like we calculate and we capitalize on this value add. The customer experience has been something that has been quite key for us as well, because it's not just a solution or a capability that we're doing in isolation. We want the feedback, we want the input from the customer, and we want to make sure that they're part of this journey. An exercise we recently did estimated that about 80% of the data they're using for asset management is deriving from the stages of design and construction. Getting all this information in silos, in PDFs, in digitized, in non-intelligent formats, let's say, sort of means that they're not getting the maximum value out of the data. And lastly, the time for data rework. A lot of the times, by working in a standardized digital system, it means that your data should be almost perfect. It never is in reality, but it is closer. It's much better than having to digitize records that are being kept on paper. So this produces massive efficiencies when it comes to preparing for a health and safety file, and essentially the handover stage of the project that can easily impact the bottom line during project closeout for an organization. So I hope you have enjoyed my presentation. Thank you very much for your attention and looking forward to the rest of the day. Thank you.